Hello students, so welcome back to my video lectures on chemical bonding and molecular structure, the fifth chapter of it is basically the fourth chapter. It is fourth chapter of 11th standard. So we were solving multiple choice questions from this chapter. So let us continue with solving the multiple choice questions. Before that, please let me correct it. It's not fifth chapter. What is it? It's basically, yes, the fourth chapter of your first 11th standard, that is chemical bonding and molecular structure. So I think we have solved so many questions on that. So how many questions we have solved? Yeah, we have finished first question, second question we have finished, third question finished, fourth is finished, fifth is finished, sixth, seventh, eighth is finished, ninth is also finished. I think fifth one I told you that I'll be solving it later because it is a question from organic chemistry. We will take up the questions of organic chemistry at the later part of solving the MCQs. Yes, so we have finished up to 9 questions, and the answer for the last question was supposed to be ICl2 plus. That is option D. Now let us go with the 10th question. Yes, the question says, read out the question, please read the question, understand the question. Only when you understand the question, see, if you understand the question, you are 90% finished in solving the problem. So everything depends on how you understand the question. So please understand the question there. So two atoms of an element having half-filled orbitals with the same spin overlap. What happens according to valency bond theory? Two atoms of an element having half-filled orbitals with the same spin overlap. What happens according to the valency bond theory? Such bonds lead to the bond formation. Such overlap will not lead to bond formation. Such overlap leads to form a sigma bond. Such overlap leads to form a pi bond. What is the correct answer? Hope you have understood the question. Two atoms of an element having half-filled orbitals with the same spin. The question is same spin. See students, according to valency bond theory. Let me explain this. According to what? Valency bond theory. Valency bond theory. See, if I consider the formation of hydrogen molecule, H2 molecule. Let us consider the formation of H2 molecule, hydrogen molecule. See, hydrogen atomic number is 1 and its electronic configuration is 1s1, isn't it? So that means hydrogen has 1 proton and 1 electron. Hydrogen has 1 proton and 1 electron. So if hydrogen molecule has to be formed, so the two hydrogen atoms, see, according to valency bond theory, a covalent bond is formed by the overlapping of atomic orbitals. The covalent bond is formed by the overlapping. If the atomic orbitals overlap, there will be a bond formation, and that bond formed is called as covalent bond. Now, so if hydrogen molecule has to be formed, the atomic orbitals of one hydrogen should overlap with the atomic orbitals of another hydrogen. Only when atomic orbital of one hydrogen overlaps with the atomic orbital of another hydrogen, a covalent bond is formed between the two hydrogen atoms, and therefore it gives rise to the formation of hydrogen molecule. Hope you are able to understand what I say. I repeat again. So if hydrogen molecule has to be formed, the atomic orbital of one hydrogen should overlap with the atomic orbital of another hydrogen. Look here, this is one hydrogen, and let us take another hydrogen atom. Another hydrogen atom also has 1 proton and 1 electron. Now, so if the atomic orbital of this hydrogen overlaps with the atomic orbital of this hydrogen, it gives rise to the formation of hydrogen molecule. It will form what? Hydrogen molecule. Okay, isn't it? So if the atomic orbital of this hydrogen overlaps with the atomic orbital of this hydrogen, okay, hydrogen molecule is formed, no doubt in it. But there is conditions for overlapping. Okay, what are the conditions for overlapping? Conditions for overlapping. Not all the orbitals can overlap each other. Not all the atomic orbitals can overlap each other. Yes, there are certain conditions for overlap. Not simply this atomic orbital cannot overlap with this atomic orbital as such. There are conditions for overlapping. What are the conditions for overlapping? One thing is, okay, yeah, overlapping atomic orbitals must have, okay, what? Unpaired electrons. Must have what? Unpaired electrons, and these unpaired electrons must be in opposite spin. Must be in what? Opposite spin. Okay, okay, must with opposite spin, not same spin. What is it? Opposite spin. Yes, the atomic orbitals must have unpaired electrons with opposite spin. Okay, that means if this, okay, I don't know, if the electron of this hydrogen is spinning in clockwise direction, the electron of this hydrogen should be in opposite, should have opposite spin. Only when the two electrons, okay, two unpaired electrons are in opposite spin, then the atomic orbitals will overlap, then there is formation of covalent bond, and then there is formation of hydrogen molecule. This is the condition. The other condition is, okay, the atomic orbitals must come close to each other, for maximum overlapping. For what type of overlapping? Maximum overlapping. Okay, because more the overlapping, stronger will be the bond. Okay, so these two atomic orbitals should come very close to each other. When the two atomic orbitals come very close to each other, okay, the extent of overlapping will be more the overlapping, stronger is going to be the bond. So I think one condition is very clear. Atomic orbitals that are undergoing overlapping should have unpaired electrons, and those unpaired electrons should be in opposite spin. This is one condition. The other condition, the atomic orbitals should come close to each other, so they now overlap to a maximum extent. More the overlapping, stronger will be the bond. See, apart from these two conditions, students, there is one very important condition. What is that? The third important condition is, okay, yes, the overlapping atomic orbitals, must be of comparable energy. Must be of comparable energy. Must be of comparable energy. Only when these three conditions are fulfilled, overlapping takes place. If overlapping takes place, covalent bond is formed. If covalent bond is formed, then a molecule is going to be formed, isn't it? Okay, please understand the last condition. What is the last condition? The overlapping atomic orbitals, that means the atomic orbitals which are involved in overlapping should be of comparable energy. Look at here, students. If hydrogen molecule has to be formed, which are the atomic orbitals that are undergoing overlapping here? 1s orbital of one hydrogen, okay, 1s orbital of one hydrogen is overlapping with 1s orbital of another hydrogen, okay, and we know that they are of same energy. 1s orbital of one hydrogen is of same energy as that of 1s orbital of another hydrogen. They are of same energy. Only when the two orbitals which are, okay, undergoing overlapping have same energy, they can overlap, they can form a covalent bond, and it results in the formation of a molecule. So only when these three conditions are fulfilled, okay, then overlapping takes place and it results in the formation of molecule. Now let us come back to the question. What is the question? Two atoms of same element having half filled orbital with the same spin overlap, what happens according with the same spin? if two atoms of an element having half-filled orbitals with the same spin overlap, what happens according to valency bond theory? What is the condition? The atomic orbitals must have unpaired electrons and they should have opposite spin. But here the overlapping takes place with the same spin. If the overlapping takes place with the same spin, then is there any bond formation, students? No, there is no bond formation. There is no bond formation. Hence, what is the answer? Such bond leads to bond formation? No. Okay. Such overlap will not lead to bond formation? Yes. Such overlap will not lead to bond formation. If a bond has to be formed, then the electrons must have opposite spin. But here the condition given is the electrons has same spin. If the electrons have same spin, then the overlapping will not take place. If the overlapping does not take place, then there is no bond formation. Hence the correct answer is option B. Such overlap will not lead to bond formation. Bond formation. Is that simple? Okay. Yes, that's so great. Okay, next question. Okay, next question, students. Which of the following bonds is least polar? Okay, which of the following bonds is least polar? If you don't mind, I will have a sip of water. Yeah, the question is, which of the following bonds is least polar? Okay, see, I told you, okay, that polarity depends upon electronegativity difference. Okay, electronegativity difference. Yes, electronegativity difference, correct? Okay, polarity depends upon electronegativity difference. Okay, larger the electronegativity difference, more will be the polarity. Lesser the electronegativity difference, lesser will be the polarity. Lesser will be the polarity. That's how it goes. Okay, so higher the electronegativity, okay, more will be the polarity. More will be the polarity. Yes. Lesser the electronegativity, lesser will be the polarity. Lesser will be the polarity. Okay, more the electronegativity, more is the polarity. Lesser the electronegativity, lesser is the polarity. Okay, so students, I have hydrogen fluoride, hydrogen chloride, hydrogen and oxygen, and hydrogen and sulfur. So which of the following bonds is least polar? Least polar means, okay, then the where the electronegativity is very less, then that bond is going to be less polar. The bond is going to be less polar. So here we have hydrogen and fluorine. Fluorine is highly electronegative. Okay, so that means this bond is highly polar. Okay, hydrogen chloride is also more electronegative. Okay, more electronegative. It is more electronegative than what? Oxygen. Okay, oxygen is more electronegative than sulfur. Okay, so sulfur is less electronegative than oxygen. Oxygen is less electronegative than chlorine. Chlorine is less electronegative than fluorine. Less electronegative than fluorine. So fluorine is highly electronegative. Therefore, this bond is highly polar. Okay, next comes chlorine, next comes oxygen, next comes sulfur. Okay, sulfur is least electronegative. Since sulfur is least electronegative, lesser the electronegativity, lesser is the polarity. So which of the following bonds is least polar? Yes, it is option D. Okay, HS bond is least polar. Okay, is that simple? Okay. Yes. Okay, students, next question. Okay, yeah, the bond angle of a molecule involving sp3 hybridization in which the central atom has 3 bond pairs and 1 lone pair. Okay, the bond angle of a molecule involving sp3 hybridization in which the central atom has 3 bond pairs and 1 lone pair. Okay, so he is telling, okay, the central atom, okay, central atom is surrounded by 3 bond pairs and 1 lone pair. 3 bond pairs and 1 lone pair. See, students, have told you, if the central atom is surrounded by both bond pairs and lone pairs, okay, if the central atom is surrounded by both bond pairs and lone pairs, then we say that as irregular geometry, isn't it? We call it as irregular geometry. Is that correct? We call this as irregular geometry. But if the central atom is surrounded only by bond pair, then it is called as regular geometry. Understood? Okay, if the central atom is surrounded both by bond pairs and lone pair, irregular geometry. If the central atom is surrounded only by bond pair, it is regular geometry. So the question is talking about irregular geometry, isn't it? Okay, because the central atom has 3 bond pairs and 1 lone pair, that means it is irregular geometry. Okay, irregular geometry. See, okay, he has given sp3 hybridization. Okay, sp3 hybridization. Okay, sp3 hybridization, isn't it? So students, okay, if the sp3 hybridization is in regular geometry, if the sp3 hybridization is in regular geometry, okay, then the shape of the molecule is to be tetrahedral. The shape of the molecule is going to be tetrahedral, and we know the bond angle for tetrahedral structure. What is it? It is 109 degree 28 minutes. 109 degree 28 minutes. Is that correct? Okay, so if the sp3 hybridization is in regular geometry, then the geometry of the molecule is going to be tetrahedral and the bond angle is going to be 109 degree 28 minutes. This is for regular geometry. But the given geometry is irregular geometry. Look at here, the central atom has 3 bond pairs and 1 lone pair. So the given question is for irregular geometry. See, okay, observe this question. Note this point. Please note this point. Okay, see, if the sp3 hybridization, okay, yes, is for irregular geometry, if it is for irregular geometry, okay, yes, then the structure is going to be a pyramidal structure, okay, yes. So if it is regular, tetrahedral structure. If it is irregular sp3, then it is pyramidal, and here the bond angle is less than 109 degree 28 minutes. Okay, the bond angle will be less than 109 degree 28 minutes. Why? The reason for, okay, lesser bond angle here is because of the repulsion between lone pair and bond pair of electrons. It is because of the repulsion between what? Lone pair and bond pair of electrons. Is that simple? I'll give you an example, don't worry. I'll give you an example, okay? For regular geometry sp3 hybridization, I'll give you an example. For irregular geometry sp3 hybridization, I'll give you an example, okay? Yes, simple, okay, sp3 regular tetrahedral 109 degree 28 minutes, okay? sp3 irregular pyramidal less than 109 degree 28 minutes. Therefore, obviously the answer for this question will be, okay, of course it is option C, 109 degree 28 minutes, okay? What is the answer for this? Okay, what is the reason why the bond angle is less than 109 degree 28 minutes? It is because of the repulsion between lone pair and bond pair of electrons. Lone pair and bond pair of electrons. Okay, now let me explain this regular sp3 and irregular sp3 with an example, so that why the bond angle is less than 109 degree 28 minutes is justified. Okay, yes. Okay, let me give an example. Okay, look at here. Yes, I'll take the example of methane and I'm going to take the example of ammonia, NH3. Methane and ammonia. See, methane is sp3 hybridized. Yeah, nitrogen is also sp3 hybridized. sp3 hybridized. But look at the difference here. See, methane is surrounded tetrahedrally by 4 hydrogen atoms. Okay, methane is surrounded, in methane, carbon is surrounded tetrahedrally by 4 hydrogen atoms. So you can observe carbon is surrounded only by bond pair of electrons. Carbon is surrounded only by what? Bond pair of electrons. There are no lone pair of electrons around carbon. Okay, if there are no lone pair of electrons around carbon, okay, therefore this sp3 is regular geometry. Okay, regular geometry. And what do you call this shape as? What do you call the geometry of methane as? It's tetrahedral. It is tetrahedral. And we know, according to valency shell electron pair repulsion theory, the repulsions between bond pair will be very less. What is the order of repulsion according to valency shell electron pair repulsion theory? Yeah, lone pair of electrons will repel more than lone bond pair of electrons, which repel more than bond pair of electrons. Which repel more than bond pair of electrons, isn't it? Lone pair repel more than lone bond pair, which repel more than bond pair of electrons. So you can observe the repulsion between bond pair of electrons is least. Okay, so the repulsion is least, and what is the expected bond angle? What is the expected bond angle? The bond angle is 109 degree 28 minutes. Okay, now coming on to ammonia. Okay, see, ammonia is it is also sp3 hybridization. Okay, that means 4 hybrid orbitals, no doubt in it, 4 hybrid orbitals. Whereas using 3 hybrid orbitals, it will form bond with the 3 hydrogen atom, and the other hybrid orbital contains a lone pair of electrons. The other hybrid orbital contains lone pair of electrons. Now, so in this species, in this molecule, there is both lone pair as well as bond pair, isn't it? In this species, there is both lone pair as well as bond pair. So what do you call this geometry as? sp3, irregular geometry. It is what? Irregular geometry. This species has irregular geometry, correct? Okay, and if it is sp3 irregular geometry, what do you call the shape as? The shape of this molecule is going to be what? Pyramidal. The shape of this molecule is pyramidal shape or pyramidal geometry. And what about the bond angle? I told you the bond angle is less than 109 degree 28 minutes. Okay, why the bond angle is less than 109 degree 28 minutes? Because consider the order of repulsion. Okay, lone pair repel more than lone pair bond pair, which repel more than bond pair. So here there is more repulsion between lone pair and bond pair. Okay, since there is more repulsion between lone pair and bond pair, the bond angle will get contracted. Okay, when the bond angle gets contracted, the bond angle will be less than 109 degree 28 minutes. So since this lone pair of electrons are repelling this bond pair and this lone pair is repelling the bond pair, the bond angle gets contracted, and hence the bond angle will be less than 109 degree 28 minutes. 109 degree 28 minutes. Okay, is that clear? So what is the correct answer? C. Yes, exactly. Yes. Okay. Next question, students. Just a minute. Okay. Next question. Which of the following represents, okay, the following sequence of hybridization? sp2, sp2, sp, sp from left to right. Okay, so which of the following represents the following sequence of hybridization: sp2, sp2, sp, sp, from left to right. Okay, so he's given different organic molecules. Okay, in which of the molecules the hybridization is sp2, sp2, sp and sp. Again, this question is also from organic chemistry students, but this question answer can be, we can answer this question by using the concepts of chemical bonding. Okay, we can answer this question by using the concepts of what? Chemical bonding. Okay, so now I told you that, so you can go back to my previous videos and just watch my previous video, that carbon can undergo only 3 types of hybridization. Yes, it will undergo only 3 types of hybridization. What are that? Okay, they are sp, sp2 and sp3. Okay, yes, if it is sp, linear, sp2 trigonal planar, okay, yes, sp3 tetrahedral, okay, yes. See, okay, linear means 180 degree, trigonal planar means 120 degree, tetrahedral means 109 degree 28 minutes, 109 degree 28 minutes. Look at here, students. When do you say that the carbon is sp hybridized? When will you say that carbon is sp2 hybridized? Or when will you say that carbon is sp3 hybridized? Carbon is sp3 hybridized. See, if carbon is surrounded only by single bond, please learn the shortcut. Okay, so if carbon is surrounded only by single bond, then that carbon is sp3 hybridized. What type of hybridized is this, students? It is sp3 hybridized. If the carbon has one double bond, then it is sp2 hybridized. If the carbon has one double bond, then it is sp2 hybridized. If the carbon has two double bonds or one triple bond, if the carbon has two double bond or one triple bond, then this carbon is going to be sp hybridized. Okay, I hope you can see this. So if carbon is only, if it is surrounded only by single bond, it is sp3. If the carbon has one double bond, sp2. If the carbon has two double bonds or one triple bond, then that, okay, species is going to be sp hybridized. Okay, yes. Now let us take the options and let us see which compound will follow this sequence: sp2, sp2, sp, sp, from left to right. Okay, yes, from left to right. Okay, I'll take the first option, students. Okay, first option says CH2, okay, double bond, CH, single bond, okay, C, triple bond, CH, okay, yes, CH2, double bond, CH, single bond, C, triple bond, CH. See this carbon has one double bond, that means it is sp2 hybridization, correct? Yes, this carbon also has one double bond, it means it is also sp2 hybridized, isn't it? This carbon has one triple bond. If carbon has one triple bond, then it is obviously sp hybridized. Again, this carbon has one triple bond, then it means it is also sp hybridized. Look at here, sp2, sp2, sp, sp hybridization from left to right. Okay, therefore the answer has to be option A. Okay, now if you consider option B, look here, CH, triple bond C, single bond C, triple bond CH. What is the state of hybridization of this molecule? Carbon with one triple bond, sp. Carbon with one triple bond, sp. Carbon with one triple bond, sp, and carbon with one triple bond is sp. So here all the carbon atoms are sp hybridized. Next, if I take the next option, CH2, double bond, C double bond, C double bond, CH2. Okay, carbon with one double bond, sp2, correct? Carbon with two double bonds, sp. Carbon with two double bonds, sp. Carbon with one double bond, sp2. Okay, so what is the sequence of hybridization here? sp2, sp, sp and sp2. And if I go with the last option, okay, CH2 double bond, CH single bond, CH double bond, CH2. Observe here, carbon with one double bond, sp2, carbon with one double bond, sp2, carbon with one double bond, sp2, and carbon with one double bond, sp2. Okay, so here all the carbon atoms are sp2 hybridized. So the given sequence is sp2, sp2, sp, sp from left to right. Therefore, the correct answer is option A. Option A. Okay, simple, very simple. Okay, yes. Yeah. Okay, students, next question. Next, okay, the factors that do not affect ionization energy. The factor that does not affect ionization energy. Okay, basically, students, this question should be from chapter 3, that is, okay, classification of elements and periodicity in properties. But still, let us answer. The factor that does not affect ionization energy. Well, ionization energy depends upon so many factors. What do you mean by ionization energy? Yes, what is ionization energy? Can you tell me what is ionization energy? Okay, it is the amount of energy required to remove an outermost electron, outermost electron from an isolated, okay, required to remove an outermost electron from an isolated, yes, gaseous ground state atom, from an isolated gaseous ground state atom. It is the amount of energy required to remove an outermost electron from an isolated gaseous ground state atom. See, from any atom, from an isolated gaseous ground state atom, the condition has to be fulfilled. What is it? It should be an isolated gaseous and ground state atom. Okay, so from any atom, if I have to remove an electron, okay, and form M plus, I should supply energy. Okay, only when I supply energy to this atom in isolated gaseous ground state atom, it will lose an electron and it forms what? M plus. Okay, so the amount of energy required to remove an outermost electron from an isolated gaseous ground state atom is called as ionization energy. Well, ionization energy depends upon so many factors. What is that? Okay, well, ionization energy, see this, ionization energy is inversely proportional to atomic size. Okay, lesser the atomic size, more is the ionization enthalpy. Okay, lesser the atomic size, more is the ionization enthalpy. That means ionization energy is directly proportional to atomic size. The second thing is, ionization energy is directly proportional to effective nuclear charge. Okay, ionization energy is directly proportional to what? Effective nuclear charge. Higher the nuclear charge, more will be the ionization energy. Lesser the nuclear charge, lesser will be the ionization energy. Okay, according to the question, the factor that does not affect ionization energy is, okay, the factor that does not affect ionization energy is, well, is it about the size of atom? Well, yeah, atomic size will affect ionization energy. Charge on the nucleus, yes, it will affect okay, ionization energy. Type of bonding or type of electron involved. Okay, yes, the factor that does not affect ionization energy is the option C. It is type of bonding. Type of bonding has nothing to do with ionization energy. Okay, type of bonding has nothing to do with ionization energy. Even the type of electron, whether it is s electrons or p electrons or d electrons or f electrons, okay, the type of electrons will play an important role in ionization energy, but the type of bonding has nothing to do with ionization energy. Hence the answer for this question is option C. Option C, correct. Okay. Okay, students, now the next question. Okay, which among the following statements regarding covalent compound is true? Okay, yes, which among the following statements regarding covalent compound means covalent bond. Okay, yes, option A, the electrons are shared between the atoms, the bond formed may be polar or non-polar, the strength of the bond depends upon the extent of overlapping, and the bond is non-directional. Which among the following statements regarding covalent compound? Okay, the answer, the question has to be which among the following statement regarding the covalent compound is not true. Okay, if the question is true, okay, then we get so many answers. It's a multiple answer question. Okay, but if the question is not true, then we have only one answer. Okay, so which among the following statements regarding covalent compound is true? We know, I just told you in the previous videos, a covalent compound means, okay, a covalent compound involves what? Covalent bond. Okay, a covalent bond is formed by what? Yes, sharing of electrons between the two atoms. Sharing of electrons between the atoms, isn't it? Okay, the bond formed by sharing of electrons between the atoms is called as covalent bond. Okay, I also told you, according to valency bond theory, VBT, okay, according to valency bond theory, a covalent bond is formed by the overlapping of atomic orbitals. Didn't we discuss this? Okay, yes or no? A covalent bond is formed by the overlapping of atomic orbitals. What is the condition for overlapping? The atomic orbitals must have unpaired electrons with opposite spin, and they should come closer so that the extent of overlapping is maximum, isn't it? Etc, etc. Okay, we discussed so many things here. According to valency bond theory, a covalent bond is formed by overlapping of atomic orbitals. A covalent bond involves sharing of electrons between the atoms. That is correct. Okay, see, if I consider hydrogen molecule and hydrogen fluoride molecule, this is also covalent bond. This is also covalent bond. Here hydrogen is sharing one electron, this hydrogen is sharing one electron. It forms a covalent bond. Okay, here hydrogen is sharing one electron and fluorine is sharing one electron. It's a covalent bond. See, what type of covalent bond is it? It's a non-polar covalent bond. Non-polar covalent bond. Why this bond is non-polar? Because, okay, I have told you, if the compound has to be polar, there should be electronegativity difference. But here, the two hydrogen atoms are equally electronegative. The two hydrogen atoms are equally electronegative. Since the two hydrogen atoms are equally electronegative, this molecule is polar. But here there is electronegativity difference. Fluorine is more electronegative than hydrogen. Okay, that means there is electronegativity difference. If there is electronegativity difference, obviously the molecule is a polar covalent molecule. Polar covalent molecule. So this is polar covalent molecule, this is non-polar covalent molecule. Okay, now hope you got the answer. Okay, which among the following statements regarding covalent compound is not true? Please correct it. It is not true. The electrons are shared between the atoms. Obviously, very true. Okay, a covalent bond is formed by sharing of electrons between the two atoms. Correct. Okay, the bond formed may be polar, just like hydrogen, or non-polar. Sorry, polar like hydrogen fluoride, non-polar like hydrogen. Okay, it may be no polar as well as non-polar. Correct. Okay, the strength of the bond depends depends upon extent of overlapping. More the overlapping, more will be the strength of the bond. Lesser the overlapping, lesser will be the strength of the bond. So this is correct. Correct. So which is not true? Option D is not true, because see how many times I've told you, covalent bond is directional. Covalent bond is directional, whereas ionic bond is non-directional. Ionic bond is non-directional. Okay, so but here, okay, the bond is given as non-directional. No, the covalent bond is directional. Hence the incorrect statement is option D. Okay, simple. Yes. See, like this, if you know the concepts strongly, students, if you are very well crammed with the concepts, you can directly answer this question. It will take less than a minute, less than 30 seconds, less than 15 seconds. Okay, by reading, by looking at the options itself, we can get the answer, if and only if you are thorough with the concepts. Okay, yes. So if you don't know the concepts, you have to think a lot. Okay, yes, you have to use the logic, lot of things. But if you know the concepts, okay, you can directly go ahead with the answer. Yes, I'll take the next question now. I'll take the next question. Dipole moment is highest for. Okay, dipole moment is highest for. Okay, what do you mean by dipole moment, students? Okay, I told you. What is dipole moment? Dipole moment. Yes. See, if I consider hydrogen fluoride, very well known concept. Okay. Yes. So, okay, hydrogen will share one electron, fluorine will share one electron, and they form a covalent bond. Correct. But fluorine is more electronegative than hydrogen, isn't it, students? Okay. Fluorine is more electronegative than hydrogen. Since fluorine is more electronegative than hydrogen, the shared pair of electrons will be, okay, withdrawn by fluorine, or fluorine will withdraw the shared pair of electrons towards itself. When fluorine withdraws the shared pair of electrons towards itself, fluorine will get partial negative charge and hydrogen will get partial positive charge. Correct? Fluorine will get partial negative charge and hydrogen will get partial positive charge. So now dipole is produced. Dipole is produced due to the electronegativity difference between hydrogen and fluorine. Now, for such a molecule, for what type of molecule? For dipole, if the bond is dipole, okay, I told you, when do you say that the bond is dipole? Only when there is electronegativity difference, isn't it? So, if the bond is dipole, for such a molecules, we define something called as dipole moment. We define, okay, dipole moment, which is denoted as mu. Okay, so what is dipole moment? Dipole moment is defined as the product of either of the two charges. Okay, the product of either of the two charges and the distance between the two charges. The distance between the two charges. Are you getting it? Dipole moment is defined as the product of either of the charge and the distance between the two charges. So mu is equal to Q into D. And what is the unit of dipole moment? The unit of dipole moment is dBi. What is the unit of dipole moment? It is dBi, which is denoted by the capital letter D. Okay, come again. What is dipole moment? Okay, it is the product of either of the charges and the distance between the two charges. See, okay, dipole moment is a vector quantity. Dipole moment is a vector quantity. Okay, what do you mean by vector quantity? It has got both direction. As well as magnitude. Okay, it has got both direction as well as what? Magnitude. Direction as well as magnitude. Okay, yes, magnitude as well as direction. Understood? Okay, so well, dipole moment, it is Q into D, that means it has some magnitude. And dipole moment is always directed towards a more electronegative atom. Dipole moment is directed towards a more electronegative atom, more electronegative. Among hydrogen and fluorine, which one is more electronegative? Fluorine is more electronegative. Therefore, the dipole moment is towards what? Fluorine. We will write it with an arrow mark with a tail at its end. We'll write it with an arrow mark with a tail at its end, So this is how we represent the direction of the dipole moment. Okay, what is the direction of the dipole moment? The dipole moment is directed towards a more electronegative atom, So we'll write it with an arrow mark with a tail at its end. Are we clear? Yes. Okay. So dipole moment is a vector quantity which involves both direction as well as magnitude. Okay. Yes. Now coming on to the question. Well, dipole moment is highest for what? Is it for methane, carbon tetrachloride, chloroform or fluoroform? Chloroform. Okay. Look here and please one more concept. Okay, higher the electronegativity, yes, more will be the dipole moment. Please mark this, very important. Higher the electronegativity, more will be the dipole moment. Hope you understood all these concepts. Okay, yes, mu is q into d, and the unit of mu is dpi. Dipole moment is a vector quantity. It has got both direction as well as magnitude. What is the direction of the dipole moment? Okay, dipole moment is always directed towards a more electronegative atom. So how do you represent it? We represent it with an arrow mark with a tail at its end. Okay, so and what else? Higher the electronegativity, more is the dipole moment. Okay, now let us solve this question with these concepts. Yeah, according to the question, the dipole moment is highest for, is it for methane, carbon tetrachloride, chloroform or fluoroform? If I consider methane, students, methane, CH4. Students, we know that carbon and hydrogen are equally electronegative. There is no electronegativity difference between carbon and hydrogen at all. If there is no electronegativity difference, there is no charge separation. If there is no charge separation, there will be no dipole moment. That means, what will be the dipole moment of this molecule? Of course, it is 0. The dipole moment of this molecule is 0. Okay. Why the dipole moment is 0? Because both the atoms are equally if you consider any bond, okay, dipole moment is defined for each and every bond. It is defined for each and every bond. What is the dipole moment? No dipole moment, because both are equally electronegative. What about this bond? No dipole moment, no dipole moment, no dipole moment. Hence, the net dipole moment of the whole molecule is 0. Remember, if the dipole moment is 0, then we call that molecule as non-polar molecule. Non-polar molecule. What do we call it as? We call it as non-polar molecule. Non-polar molecule. Understood? Is that simple? Yes. Now, if I consider carbon tetrachloride, students, carbon tetrachloride. Look at here. Yes, there is one interesting concept. See, now chlorine is more electronegative than carbon. That means there is electronegativity difference. If there is electronegativity difference, there will be dipole moment. Well, now what is the direction of the dipole moment? The dipole moment will be directed towards more electronegative atom. That means for this bond, the dipole moment is towards chlorine. Okay. For this bond, the dipole moment is towards chlorine. For this bond, the dipole moment is towards chlorine. And for this bond also, the dipole moment is towards chlorine. Look here, don't you think these two are equal and opposite dipoles? Yeah, they are equal and opposite dipoles. These two are equal and opposite dipoles. We know equal and opposite, okay, quantities will cancel each other. Equal and opposite dipoles will cancel each other. Therefore, okay, because of these two equal and opposite force, now dipole moment is 0. These two are also equal and opposite dipoles, isn't it? These two are also equal and opposite dipoles. So these two are also equal and opposite dipole means what is the net dipole moment on this molecule? The net dipole moment on this molecule will be 0. The net dipole moment on this molecule is 0. Okay. Hence, this molecule is also what? This molecule is also non-polar. Okay, this molecule is also non-polar. Very good. Okay, yes. How about next? I'll take chloroform, students. Chloroform. Okay, CHCl3. Yes, consider this CHCl3. Okay, how about this bond? Is there any dipole moment of this bond? No, because carbon and hydrogen are equally electronegative. There is no electronegativity difference. Therefore, there is no dipole moment in this bond. Okay, but for this bond, yeah, chlorine is more electronegative than carbon. Since chlorine is more electronegative than carbon, okay, so chlorine withdraws the pi electrons towards itself. Hence, there is a dipole moment. And what is the direction of dipole moment? Yes, the direction of this dipole moment is towards chlorine. What is the direction of this dipole moment? It is towards chlorine. What is the direction of this dipole moment? It is towards chlorine. Understand here, okay, these two are equal and opposite dipoles. These two will cancel. These two will cancel. But there is a dipole moment here, right? But this doesn't cancel. There is a dipole moment. There is a dipole moment. Okay, let us take that dipole moment as x d by. No doubt. Because we don't know the dipole moment, exact dipole moment, let us consider it as x d by. Okay, simple. These two are equal and opposite dipoles, they cancel. There is only one dipole moment towards chlorine. Now if I consider fluorine, okay, CH, okay, F3. Again, is there any dipole moment? Okay, can you define dipole moment for this bond? No, because carbon and hydrogen are equally electronegative. Can we define a dipole moment for this bond? Yes, because fluorine is more electronegative than carbon. What is the direction of dipole moment? It is towards fluorine. Here the dipole moment is towards fluorine. Here the dipole moment is towards fluorine. Again, these two are equal and opposite dipoles. Since these two are equal and opposite dipoles, they cancel each other. Therefore, we have only one dipole moment in this direction. Is it correct? Only one dipole moment. Let us take that dipole moment as y d by. Now, we have x d by and y d by. Which among them is the highest? Anyhow, the dipole moment of this molecule is 0. The dipole moment of this molecule is 0. But we have the dipole moment of this molecule and we have taken it as x dipole, x d by. And we, this molecule also has certain dipole and we have taken it as y d by. Okay, among x and y, which one is greater? I have given you one statement. Higher the electronegativity, higher is the dipole moment. Well, between chlorine and fluorine, which one is more electronegative? Of course, fluorine is more electronegative. More the electronegativity, more is the dipole moment. Hence, the dipole moment is highest for, yes, it is option D. Okay, dipole moment is highest for, okay, now fluoroform. Okay, understood? Okay, fluoroform. Okay. Okay, next question. Yes, I'll take up the next question. What is it? Among ClF3, BF3 and ammonia molecules, the one with regular geometry is. Among ClF3, BF3, NH3 molecules, the one with regular geometry. Students, how many times I should tell you? What is regular geometry? What is irregular geometry? Yes, come on. Simple question. Okay, regular geometry, and irregular geometry. Regular geometry and irregular geometry. Come on, what is regular geometry and what is irregular geometry, students? If the central atom, okay, has, okay, only bond pair of electrons, it is regular geometry. If the central atom has both bond pair and lone pair of electrons, then it is called as irregular geometry. Now we have to just check which of them has regular geometry. Students, I'll take ClF3. Okay, ClF3. Okay, so here the central atom is chlorine. Okay, usually less electronegative atom should be taken as central atom. Okay, usually, okay, less electronegative atom should be taken as what? Central atom. Okay, so therefore we have chlorine and fluorine. We know chlorine is less electronegative, hence chlorine is the central atom, isn't it? Chlorine is the central atom. Now chlorine, we know chlorine is an halogen. Halogen belongs to 17th group. Halogen belongs to which group? 17th group. For 17th group, okay, the number of valence electrons is going to be 7. For 17th group, the number of valence electrons is 7. Okay, so chlorine has 7 valence electrons. Out of 7 valence electrons, it has used 3 valence electrons to form bond with fluorine. Okay, out of 7 valence electrons, it has used 3 valence electrons to form bond with fluorine. That means, okay, the 4 electrons will be what? Lone pair of electrons. The remaining 4 electrons will be lone pair of electrons. Simple. Out of 7 electrons, it has used 3 electrons to form bond with fluorine, and the remaining 4 electrons will be, what? Lone pair of electrons. That means to say, students, chlorine is surrounded by both bond pair as well as lone pair. Okay, chlorine is surrounded by both bond pair as well as lone pair. So what type of geometry is it? It is irregular geometry, isn't it? It is irregular geometry. Very simple. Okay, is that simple? Yeah. Next, if I consider boron trifluoride, among boron and fluorine, which is less electronegative? Obviously boron. So boron is the central atom. Boron belongs to 13th group. For 13th group elements, the number of valence electrons will be equal to 3. For 13th group, the number of valence electrons will be 3. That means boron has 3 valence electrons. It has used all the 3 valence electrons to form bond with 3 fluorine atoms. Boron has only 3 valence electrons. It has used all the 3 valence electrons to form bond with fluorine. That means boron has no lone pair. It has only bond pair. If boron has only bond pair, what do you call this geometry as? Yeah, it is regular geometry. So according to the question, among ClF3, BF3 and ammonia molecules, the one with regular geometry, yes, of course, it is BF3, boron trifluoride. Let us also check with NH3. Okay, let us also check with NH3. Now here, see here, no, we cannot use a rule, I just told. Okay, less electronegative atom should be taken as central atom. But here nitrogen is more electronegative than hydrogen, but still nitrogen is central atom. Nitrogen is going to be central atom. Usually carbon and nitrogen, even though they are more electronegative, they will be central atoms. Okay, yes. So nitrogen belongs to what? 15th group. 15th group elements will have 5 valence electrons. 15th group elements will have 5 valence electrons. Out of 5 valence electrons, nitrogen has used 3 valence electrons to form bond with 3 hydrogen atom, and the remaining 2 will be lone pair. Okay, lone pair. So that means to say nitrogen has both bond pair as well as lone pair. So what type of geometry? Yes, it is irregular geometry. Hence, the only molecule with regular geometry is boron trifluoride. Therefore, it is the answer. Such a simple thing. Okay? Yes. Okay. Next question. Yes, students, next question. Next question is, as the p character increases, the bond angle in hybrid orbitals formed by s and p orbitals, will it increase or decrease or remains unchanged or cannot be predicted? As the p character increases, the bond angle in hybrid orbitals formed by s and p orbitals, will it increase or decrease or remains unchanged or cannot be predicted. So between s and p orbitals we have got three types of hybridization: sp, sp2 and sp3. Yes. So what is the percentage of s character and percentage of p character? Here it is 50%, 50%. Okay. Yes. How about percentage of s character and p character? Here it is 33.3% and what? Yes, 33.3% means the remaining is 100 minus 33.3%, it is 67%. Okay, or 66.37%, whatever it is. Okay, yeah, 66.7%. 7%. Yes. How about in sp3 hybridization? Okay, the percentage of s character is 25% and the percentage of p character is 75%. Okay, bond angle here it is 180 degree. Bond angle here it is 120 degree. Bond angle here it is 109 degree, 28 minutes. Just students understand, here in sp hybridization, percentage of p character is 50%. In sp2 hybridization, percentage of p character is 66.7%. In sp3 hybridization, percentage of p character is 75%. Look here, as the percentage of p character increases, as the percentage of p character increases, what is happening to the bond angle? What is happening to the bond angle? Don't you think? Okay, when it is 50%, it is 180 degree. 66.7%, 120 degree. 75%, 109 degree, 28 minutes. So as the percentage of p character is increasing, the bond angle is decreasing. Correct? Okay, as the percentage of p character increases, the bond angle decreases. So okay, very simple question it is. Okay, as the p character increases, as the p character increases, the bond angle in the hybrid orbitals formed by s and p orbitals will decrease. As the p character increases, the bond angle decreases. So answer is option B. Okay, so students, I'll continue with solving the problems in the next video also. Thank you.